Back to 2800 BC in ancient Babylon. The basic formula they had for soap included water, alkali, and cassia oil. Since then, soap making has developed its history in various other countries. Nicer soaps were developed in the 16th century Europe with vegetable oils such as avocado oil and olive oil, and animal fats. Industrially manufactured soaps came around the 18th century as the role of hygiene became more prevalent. Soaps are extremely soluble in water and are comprised of salts of fatty acids. The characteristics of soap are based off of the different types of oils and fats inside of them. Okay, hi. So I'm going to talk about the differences of soap and detergents. So soaps, as we know, are comprised of fatty acids and they contain a carboxylic acid group. So they're also natural in origin, so they come from like animals or plants. But then detergents, on the other hand, are synthetic in origin, so they can contain like an ionic group, so like sulfate, and they're more versatile than soap because they work better in any temperature, while soap works best in warm temperatures. And detergents do not leave a residue.
Sodification is the chemical reaction of soap. A strong base and a fat combine to form soap and glycerin. The NaOH attacks the O bond, and the bonds are broken. The glycerin molecules go off by themselves, and the NaOH attaches to the O because of their electronegativity and forms 3 soap molecules.
Soap, or sodium stearate, is made up of a hydrocarbon chain with a metal ion part. The metal ion part mixes with polar molecules like water, while the hydrocarbon chain mixes with nonpolar molecules like oil. When soap is used, micelles are formed. They have hydrophobic heads and hydrophilic tails. Oil is caught in the middle of the molecule, and all the micelles are washed off with water.
Hello, I'm Nathan, and I'm going to teach you how to make soap. So, the first thing you're going to do, you got to gather all your materials listed on your materials list. The second thing that you got to do is you got to weigh all the oils, fats, or butters that you chose. And then you're going to combine them in the single step pot. And then you're going to heat them on medium-low until they're all mixed together. The third thing you're going to do is you got to weigh the lye crystals in a zip-top plastic bag and seal the top. The fourth thing is you have to weigh the water in a glass or plastic bowl and set it aside for later. The fifth thing you're going to do, or fourth, I lost track, wearing protective eyewear, gloves, and a mask in a well-ventilated location, pour the lye crystals into the water, hold your breath, and stir until dissolved. Let the oil mixture in the lye water cool to 100 to 110 degrees Fahrenheit. When temperatures are equalized for the oils and lye water, carefully pour the lye water into your large pot of oils. Fully immerse a stick blender in the pot to avoid adding extra bubbles into your batter. Mix until trace. You will know it's ready when the soap begins to thicken so that it leaves a light trace or trail over the batch when spooned over the top. Add all your additives like your cool oils and stuff. Pour into a mold and design. After pouring the soap into the mold, cover and insulate by wrapping the mold in a blanket for 24 hours or cardboard. Keep gloves on and clean up. Use a lot of soap and wash immediately because it'll harden. After 24 hours, check the soap to see if it's hard enough to remove from the mold. If your fingers can mark the surface of the soap, allow it to sit another 12 to 24 hours. Remove the soap and cut if necessary. Place the bars on a shelf and rack to dry and cure. And now you have your soap.
Two of the acids that were present in the oils that we chose to use were lauric acid and oleic acid. And lauric acid has properties that give soap its purpose, like it has a high shelf life, it has a great cleansing ability, and a very efficient lather. And the lauric acid came from the coconut oil that we use to make our soap. And the other acid that's present that came from the avocado oil is the oleic acid. Can also be found in oils like olive oil. Oleic acid allows for the soap to be very conditioning, given its the structure of the molecule. And lauric and oleic acids are both components to what could be some great soap if you use them.
Okay. 1, 2, 3.
Wait. Are you filming? Okay. Okay. A base reacts with fat to form fat and glycerin.
No, don't. I look so bad. Tell me when to start.
Go.
Oh, did you already start?
Yeah, it's going. Just go. I'll cut.
Acid. And then soaps are also derived from organic compounds.
Sponification is the chemical reaction of soap. Don't kill me.
Hey, Mr. Barrett.
Okay, 3, 2, 1. Sponification is the chemical reaction of soap. A strong base and a fat molecule form more fat molecules.
What is so hard about this? That's what I don't understand. Man, this is gonna be a Molly blooper reel. Put it in the end.
Okay, wait, okay. I'm ready, okay.